In soil and water conservation engineering, let's we see earthen dam, retaining wall, and check dams. At first, earthen dam. It is constructed for long. They are constructed with the naturally available material. The construction of earthen dam up to 1930 was based mostly on experience only. But now, with the advanced knowledge of soil mechanics, these dams are designed and constructed on scientific basis. Earthen dam, which is used for storing water, very less timing. With the increased knowledge of behavior of the soil and the development of earth moving machinery, earth dams can be constructed economically even up to the height of 250 meter to 300 meters. And what are the materials used for earthen dams? Are these are the following methods. So materials which are used for constructing earthen dams. First one, clay material, black cotton soil, silty clay loam for heating and cutoffs, etc. Sandy material, soft rock, sandy silt for casting, a rock for pitching and riprap, a rock masonry, etc. Sand for filters, seepage drains, and masonry. Cement, a steel, a lime, and other building materials in small quantity for construction of spillway outlets, etc. Next, what are the types of earthen dam? Depending upon the mode of construction, earthen dam can be classified into two types. First, in a homogeneous type and second, in zone type. In homogeneous type, the sections are constructed with one type of soil only. The soil should have frictional resistance as well as low permeability and should be available in required quantities near site. And such sections are not in common practice. Next one, zone type. This type of dams are generally used for most of the peoples, and the dams are divided into two parts. First one, heating or core forming, the central impervious zone, casting or outlet shell forming, the upstream and downstream casting zone and covering of heating. The heating is made of clay soil such as black cotton soil, provide water tightness to the dam against seepage. Next one, types of earthen dam or earthen dam. In homogeneous earthen dam, the types of roll fill type and hydraulic fill dam. First one, roll fill. In this type, the earth moving machinery is used for excavating the soil, placing in layers of 20 centimeter thickness and compacting at optimum moisture content. This is a very common method for constructing earthen dams. Next one, hydraulic fill type. In this type of dam construction, excavation, transporting and placing of soil is done by hydraulic method. No compaction by rollers or sheep foot rollers is required as the soil gets consolidated during the hydraulic operations. Next one, diaphragm dam. It consists of a central impervious thin diaphragm of earth, cement concrete or bituminous concrete surrounded by earth or rock fill. The diaphragm extended through the cutoff to impervious foundation to check seepage through the dam. It may be placed either centrally or at the impervious foundation to check seepage through the dam. It may be placed either centrally or upstream face as blanket. Next one, rockfill dam. Rockfill dam have characteristics lying somewhere between the characteristics of gravity dams and those of earthen dams. In other words, they are less flexible than earthen dams and are more flexible than gravity dams. But the foundation requirements are more rigid than those of for the earthen dams, which can be constructed almost on any of the foundation. The steeper slopes are used in rockfill dams and hence the base width requires is quite less. Next, these are the advantages and disadvantages of rock fill dams. First one, cheaper but suitable hard rock is available. Suitable where material for earth dams are not available. Next, an economic in a remote location where the cost of cement for concrete dams is high. Suitable where foundation is not suitable for concrete dams can be raised subsequently if so required without much difficulties. Next, disadvantages. A time taken construction is usually more than required for concrete dam. More construction equipment is required. Next, and the foundation requirement are more rigid than earthen dams. High maintenance cost. Next one, check dams. A check dam, also called as ditch checks. is a small, sometimes temporary dam constructed across the waterways, the drainage ditches, shavels are the examples of check dams. Typically, check dams are constructed of a rock with mixed vegetation and retain some porosity, allowing of water to leak through the stones and vegetation. It counteracts erosion by reducing water flow velocity, causing sediment traps. And what are the materials which is used for check dams are rocks, sandbags, fiber logs, cement concrete, and other materials. The main function is to lower the velocity of water. Infiltration, sedimentation are added benefits. Types of check dams. First one, rock check dams. It is made of well graded stone consisting of mixture of rock size, typically from 1.5 to 12 inches for the best result. They consist of 4 to 5 feet width and the bottom is 1.5 to 2 feet width of the top, wide from the top. Next one, sandbag check dam. Sandbags made up of weathered, resistant and tightly woven geotextile fabric material sufficient to prevent leakage of fiber material. Height 1.5 to 2 feet and slide slope is about the ratio of 2 is to 1. Next, on the end of the bag is tightly abutted and overlap to a direct flow of water away from joints. Next, Gambian check dams. The Gambian is a cage which has cubic shapes filled with stony materials in a metal grating, keeping the stones together and stop them moving under the pressure of water. The techniques of Gambian check dam consist of binding different cages together to form a Gambian unit. Stony material is mixture of rocks varying in size from 1.5 to 12 inches in diameter. Next, what are the advantages of Gambians or check dams or high effective practice to reduce flow velocity in channel and waterways? Contracting a big dams have faster implementation timeline and a cost effective. And their implementation will not display peoples or communities, nor will they destroy natural resources if careful design constructions are undertaken. Simple to construct, do not rely on advanced technologies. And what are the limitations are not appropriate in channel that drains area of more than 10 acres and not appropriate in channel that are already grass lined unless erosion is expected, as installation may damage vegetation. Promote sediment trapping which can be suspended during high storms or after removal of check dams. Next, it become more difficult to establish on steep slope as velocity is higher and thereby the distance between dams must be shortened. Next one, retaining wall. Next, a retaining wall is a structure used to maintain the ground surface at different elevation on either sides of it. All the permanent wall and components should be designed to a minimum service life of 75 years. Corrosion protection is required for all permanent and temporary walls in aggressive environment. Retaining walls are usually built to hold back a soil mass. They are also provided to maintain the ground at two different levels. Next, these are the types of retaining wall. First one, gravity retaining wall, semi-gravity retaining wall, cantilever retaining wall, counterfort retaining wall. First one, gravity wall provides stability by virtue of its own weight and therefore is rather massive in size. It is usually built in stone masonry, occasionally in plain concrete gravity walls. The thickness of the wall is also governed by need to eliminate or limiting the resulting tensile stress to its permeable limit. Plain concrete gravity walls are not used for heights exceeding about 3 meters for obvious economic reasons. Stress developed is very low. These walls are proportional that no tension is developed anywhere and resultant of force remains within the middle of third of the base. Next, semi-gravity walls are resist external forces by the combined action of self-weight, weight of the soil above the footing and the fluxural resistance of the wall components. Next one is concrete or cantilever wall is an example and consists of reinforced concrete stem and base footing. These walls are not propagated. Next, cantilever wall is the most common type of retaining structure and generally economical for heights up to 8 meter. The structure consists of vertical stems, base slab made up of two distinct regions, heel slab and toe slab. Thank you.